Hi, this is Miss G. So we're going to talk about bonding. This is Unit 6. So you should have a periodic table and your Unit 6 bonding notes. So chemical bonding. Um, a bond is basically a force that holds groups of two or more atoms together and makes them function as a unit. Excuse me. So this is how the electronegativities go. So you can see that hydrogen is 2.1. Hydrogen is considered a nonmetal, and then your nonmetals are on the right side. So there's going to be a slight difference in electronegativity. So depending how big the difference is, then it depends on whether it's covalent, polar covalent, or ionic. So ionic compounds, basically, they transfer electrons. So it's used to hold ions together. So if we're ionic, we basically are, you can be a type 1 metal or a transition metal, that's our cations, and hooked up with a nonmetal or an anion to have an ionic bond. So there's a large electronegativity difference. So if we were looking at the electronegativity values between lithium and, let's say, fluorine, that's quite a difference. So it is ionic. The larger the difference, the more ionic the compound. So some examples of ionic bonds are potassium bromide. They're on opposite sides of the periodic table. Calcium chloride, also, maybe not as ionic, but it's still an ionic bond because it's a metal and a nonmetal. Transition metals and nonmetals also make ionic bonds. So if cobalt was hooked up with chloride, that's considered an ionic bond, but there's not as big of an electronegativity difference. All right, so which is more ionic, calcium sulfide or barium fluoride? So if we look at this, we can see that barium fluoride is further apart than, than calcium sulfide. So barium, okay, so barium fluoride is our more ionic. So molecular compound characteristics, nonpolar covalent are 0 to 0.4 electronegativity difference. They share electrons equally. Some examples are like N2, O2, there is no electronegativity difference. If they're polar covalent, they have a low electronegativity difference between 0.5 and 1.9. So some examples are like carbon monoxide and nitrogen monoxide. So which covalent bond is more polar covalent? So if we look at HP, we see hydrogen is 2.1 and phosphorus is 2.1. So there's no difference there. So carbon monoxide, let's look at that. So carbon is 2.5 and oxygen is 3.5. So our more covalent, polar covalent bond is carbon monoxide. So let's look at this. Ionic, nonpolar covalent, or polar covalent. So we look at calcium chloride. So you should get an electronegativity sheet. If you get your compounds or your worksheets, you can look at that. So if we look at on page 3, so calcium chloride, there is a large electronegativity difference. So we're going to say it's ionic. So this is ionic. So if we look at SO4, sulfur and oxygen, so it's, we have a difference of 1. So what we said was that if it's over 0.5, so we would say it's polar covalent bond. Again, sulfur and oxygen is a difference of 1, so again it's polar covalent. So O2, there is no difference, so we're going to just say it's covalent. So let's look at NH3. So nitrogen is 3.0 and hydrogen is 2.1. So we have a 0.9 difference. So this one is polar covalent. And we have sodium chloride, so they're across the periodic table. That's a metal and a non-metal, so it is ionic. So to wrap it up, the metal, non-metal, transition metal, non-metal is ionic. It transfers electrons. We have sulfate there. There's a slight difference in the sulfur and the oxygen. It's over the 0.5, so it's polar covalent. O2 is just covalent because there's not any difference. Okay, so let's talk with the people around you, or talk to yourself. How many valence electrons does an element have? So remember how we do this? Okay, group 1 has 1 valence, group 2 is 2 valence, group 13, or it can also be called 3, boron group is 3 valence, carbon group, group 14 or 4 is 4 valence, nitrogen group is 15 or 5 valence, oxygen, chalcogens is 6 valence. Halogens, group 17 or 7, has 7 valence electrons, and group 18 or 8 valence is the noble gases. Noble gases don't react with anything since they have a full outside shell.